Hey there, this is Jess. Welcome to another session of Raspberry Live. I'll repeat this so much that you'll have it ingrained in your senses, and that the Raspberry is a computer in the palm of your hand that can think, make, and do. So again, welcome to this session. And I had mentioned earlier that there's a lot of applications online that you can clone those for your own use. You can copy them just to learn. There's a lot of benefits in that because you learn a lot of the power and a lot of the approaches and a lot of the capabilities and basically how to navigate in some of the systems, the controls and such. But after I'd had this thing for a few months, I realized that I needed to do more than that. So I looked around the house and came up with some things. So let's go ahead and jump on down here and let's talk about one of the things that I found out that I needed. And that was a system to monitor my swimming pool. A lot of reasons. The pump pressure may get high while I'm out of town and I want to turn it off. Turn the pump off until I can see what the deal is, backwash it or maybe fix something or whatever. And if it got cold, I may want to make sure the pump is on so that I can make sure the water doesn't freeze up by keeping everything flowing. That's supposed to happen automatically, but you never know. So, and also I thought it would be a neat application to try. So the purpose of this quick demo is to show some of the power of the Raspberry Pi as I went through the design and implementation of the pool management system. And to let you know, I wrote and configured most of this program in the Node-RED programming language tool. Now I showed you some of that in an earlier session, but this actually makes full use of that for connecting, monitoring, and actuating all the different hardware devices, all the sensors and the pumps and so on. So although there's a lot of projects online, as I mentioned, that are interesting and fun to build, I wanted to do something a little bit more challenging, so I looked around the house to find something that would be useful and would convince the wife that spending this money was a good investment. And guess what? When I'm out of town, I need to manage the pool to make sure it's operating properly. Like I said, for lots of reasons: high pressure in the filter, low temperature in the at night, whatever. So I went ahead and figured out what I could do here. So this is just a high-level overview of the system I designed, programmed, built, and tested. So, what was my design life cycle? I hate to just read stuff off of a PowerPoint, but I spent a lot of time writing this, and it's pretty much how I was thinking as well. So I came up with a couple of fundamental requirements. I did this in kind of an agile manner. I did things, got it working, did things, got it working, did things, and got it working, and got enough things working to where I figured out I'm going to install it, and I'll fix everything else as it comes up. So I'm an agile type of programmer and designer and project manager, so that's how I did it. I wanted to be able to monitor the water and air temperature and the pump status. Those are the three things that I really needed to know. And I needed to have the ability to turn the pump on if I needed it for whatever reason, based on the air temperature, pump pressure, so on, and know for sure it's running. I think that's one of the main things that this control system facilitates, is it lets me know for sure that it is running. My design approach, I wanted to monitor the pump outlet pressure for a positive indication that the pump's running. So I had to add a pressure sensor to the outlet PVC piping. I'm not sure why, but very few pool control systems include a pressure sensor. So maybe that's something that tears up too much and they don't like to fix it. So anyway, I had to add one. I also added two new temperature sensors to complete my inputs to the Pi because I wanted to use some of the newer IoT stuff that had single wire serial communication automatically with the Pi. The Pi recognizes the device, and that makes it pretty simple to program. Uh, the negative side of that, I couldn't find any pressure transmitters that were IoT. So anyway, there's no analog inputs on the Raspberry Pi, so I had to add an MCP 3008 analog to digital converter for the pressure input. I used 4 output relays to interface to the pump, the cleaner, the pool lights, and the deck lights, just to take more advantage of all the power of the Raspberry Pi itself. So I'm adding, forgot to mention, I need to mention, I'm also adding a motion sensor, a camera, and some additional software that will send me an email if I put the pool in intruder detection mode. That way, if someone comes into the swimming pool area that I've got highlighted as an intruder detection area, then it will send me an email and take a couple of pictures, and it also stream it to me once I log into it. So I've got this all designed and tested, sends me emails, everything works fine. But to install it outside, I have to get me a weatherproof enclosure. I have to mount everything in a clear plastic box so the camera can be mounted in a weatherproof manner. So that'll be my next agile 2-week sprint that I'll be running here as soon as I get the weatherproof enclosure. So I don't think there's anything I didn't that I missed there. If I can find a pressure sensor later on that has a single pin interface, serial interface, they call it SFC anyway, I will get that and install that and get rid of the analog altogether. I wanted to show you a picture of what it looked like on my desk when it was all finished and tested. The Raspberry Pi is on top and the 4 output relays are there on the bottom. You will see the wiring here that connects the temperature sensors. That's actually done through better screw terminals in the field, but this was my testing scenario that I used. Worked pretty well. And also for the pressure transducer, it connects here, and I've got 2 resistors in there that split the voltage so that I can simulate the pressure transducer inside the house. So anyway, that's a picture of what it looks like, and it worked well inside, and I had absolutely no issues when I got it out to the pool housing to install it. So I want to give you a little closer look at the control system by logging into the Raspberry Pi itself. Now, take in mind, this thing is sitting outside. It's got nothing hooked up to it other than power and the sensors and the relays that control the pumps. So the remote control application is pretty simple. I've installed Apache Server on all my Raspberries, as a matter of fact. My basic operating system on my SD card includes such things as VNC Server, an Apache Server, VNC Server, let me think, what else? A lot of things, camera, all that stuff. So if you were to get an SD card from me, all that stuff would already be set up, so you wouldn't have to worry about reconfiguring your Raspberry Pi for any of these neat applications that you might want to do. So one of the nice features of Node-RED is that it will create a web page dashboard, if you ask it to, of the items you add to your program that you want to monitor. So let's just go ahead and jump to the VNC server connection and take a quick walkthrough. I've already connected, I've already logged in, I've already got the VNC server set up, and so let's go ahead and take a quick look at Node-RED. It's a programming tool. I mentioned it to you. You see the information over here in the debug screen. That's because it's running right now. It's running. It runs all the time that the Raspberry's on, and if for some reason the Raspberry loses power and starts back up, it picks up right where it was. So it's pretty robust environment, and the software is pretty cool because if you'll notice, everywhere that I've got one of these blue, this says filter pump, this symbol means that this will show up on my web page. So I have the filter pump, the pool cleaner pump, the pool LED lights, the pool deck lights. You just saw an update as it was reading another device, the pool air temperature and the pool water temperature. You'll see the pressure, PSI. You'll recognize all this text when you get over here. Now, one thing that I've never mentioned to you is the ability to go out and hook up to external databases, applications. You can do anything you can do on your computer, you can do on the Raspberry. And so I get weather information from Wonderground and Dark Sky. And when you see my web page, my control system, you will understand why I did that. It's just more of the power. Now the only problem is that when you get this, it comes in this big text string. All right, so I had to parse all that data out to get it to look right and to look like it means something. So parsing things is something else you can do very easily on the Node-RED operating system. So let me jump over to the web page that this creates for me, and you'll notice this also runs on your phone. Anywhere that you can connect to a browser, you can connect to the control system, because what I did was I punched this through my router with port forwarding, so this comes through when I'm even outside my own network. So this is actually on the DMZ. It's encrypted It's automatically encrypted and it's pretty secure. Uh, they would have to be able to log into your system to be able to get to it. So you'll notice on here the filter pump, it shows it's running. All right. And it shows that my air temperature is 64 and my pool water temperature is 51. That's live data. It also shows you for sure that the pool is running because it has 10 pounds of pressure in the filter. Now, the cool thing I mentioned about the pool weather information, this is all live from dark sky, and from the weather site Wunderground. And you'll notice it has tomorrow's forecast and current temperature. Rain starting in the afternoon, continuing until evening. Tomorrow's high is going to be, wow, 68 degrees. And tomorrow's low is going to be 55 degrees. And right now it's 58 degrees according to dark sky. And mine says 64, so it's a bright sunny day. I would say that's got a lot to do with the reading from the probe. So there's all the things that you can do. I can turn I'm not going to turn the cleaner pump on because I don't have the robot even hooked up, but I can turn the lights on in the pool. I can turn the lights on in the deck. I can do all those things. Now, one thing I cannot do is turn the pump off without an override, because I don't want to be able to turn the pump off accidentally if the temperatures are freezing. All right, so I do have to have a login override to be able to do that. But it's really cool to see your air temperature, your water temperature, and your pump pressure, and the status of everything, and be able to turn things off and on. So that's pretty much what I wanted to show you today. I wanted to show you the power of the Raspberry Pi, the ability to install Apache server, the ability to port forward this stuff out and get it outside of your own network and be able to manage, control, observe, monitor, all the things you can do that are really not a capability of an off-the-shelf laptop or PC without buying some type of external hardware for your inputs and outputs. So I hope this has been interesting. By no means was this a clear set of instructions on building a pool management system, but I will provide very detailed instructions, software, etc. to anyone who would like it, just to be able to see how it works. So if you have any questions or comments, just chat me up on Facebook, on Messenger, and I will get right back to you. And as I mentioned, the SD card that I would be glad to send to you guys already has all of the configurations that you need, including a media server if that's something you're interested in. So the SD card is well worth your time, so let me know if you need one and we'll try to figure that out. But anyway, thanks for joining, and we'll talk again soon. Thanks everyone. Have a great day.